So now we're going to start on the chapter on energy. So energy is actually defined as the capacity to do work. So for those who have actually read ahead, you know that this work or do work itself is actually referring to work done. So you can actually just say that work done is almost identical to your energy. So if you ever see the word work done itself, it just basically means energy itself. Now, energy is a scalar quantity, which means it only has magnitude and no direction, which means it cannot be negative. Okay, so because it cannot be negative itself, only the change in energy can be negative itself. So for energy itself, the SI unit is in joules. So basically energy or work done can express it in 100 joules. Okay, so the amount of energy you have, right, basically is the limit of how much or what you can do itself. So later on, we actually notice that there's one part where we talk about a system, right? The system itself usually is referring to the whole diagram that you see. So the entire, including your surroundings. So maybe you can just add this one over here, including the surroundings with a S, surroundings. Okay. So if my rocket, the total energy possessed by my rocket is only 5,000 joules, I can only travel up to a height of a certain limit until when all of my 5,000 joules is actually being used up itself. Okay, so now this is the part where it gets tricky over here. Okay, energy is no longer using our lower secondary or our primary school method of saying, oh, converted from what to what. Now we are just transferring. So keywords are, we only transfer. The only verb now is transfer, and we are going to transfer it from one energy store to another energy store itself. And the key thing is that we have different processes. Okay, so later on we're going to learn about what is energy store. Okay, what's so specific, what's so special about energy store itself, and the 4 different processes on how we can transfer energy from one store to another store. So let's look at an example of what I mean by the store type, because previously we have been using the other style, right? So normally when we're jogging itself, usually we have to have some form of energy that's being used and we can start moving, right? So the energy we use actually comes from the food that we eat. So if you notice the food that we eat, right? So the food that we eat itself comes from a specific store itself, which is most chemical potential. So remember, it's very similar to your energy, the different types of energy itself. However, now we just add the word store behind. Now, do take note, we are just transferring energy from this store to this store itself. So we don't actually transfer the entire store, because previously, right? Okay, let me just draw a bubble. So previously we always say, oh, in this case we have your chemical potential energy of the person, and we will say it is converted to the kinetic energy of the person, right? But now this is no longer in syllabus. So what we are supposed to actually say is that the energy is transferred from the chemical potential energy store of the person to the kinetic energy store of the person as well. So now it's like basically like because now a lot of times it's digital, you know, now it's like a cashless society, right? When you pay for your food, some of you just use a QR code and then you scan and you pay using your parents' debit card or whatsoever, or even your own card that your parents gave you. So it's like you just transfer your money from your account to the kopitiam auntie uncle's account itself. So you are just directly transferring your money to this. So very similar to money, energy is also transferred from one account to another account. So in this case, one energy store to another energy store itself. You don't transfer your whole energy store, your whole bank account to another person, right? You just transfer the money inside, the energy inside, to another store itself. Then later on, we're going to learn about the different processes, that how do we transfer the energy from your KE store to your kinetic energy store itself. Okay, so you can see that the terms are actually quite similar to what we have learned before. However, there are some exceptions that have been removed. Okay, so if you notice all these stores over here, what's the purpose of knowing all these stores? Because it's for us to identify what energy does the object have? Because if, number one, if I am moving, if my object is moving, you must have KE store. If I have, add in the words here, if I have a vertical height. If I have a vertical height, therefore I must have GPE. Right? Exactly, almost exactly the same as the one before, just that we now introduce the term store itself. So now even basically energy, there is no different types. We just call it energy. It's just pure energy. There's no special type of energy, but you can still loosely use it and call it kinetic energy, gravitational potential energy. However, if you are describing about the energy transfer itself, you must be specific and you must mention about the store. However, when you're doing calculations, that one is a different issue. You can actually simplify it further. Okay, so that's the next update, is that the thermal or your heat itself, we don't call it heat energy store, we don't call it thermal energy store, we call it internal energy store itself. So this part is the one that is brand new and the one you need to look out for. Okay, then your electrostatic energy, this one I would say not so much, not so, these two is out of syllabus, I would say. Okay, but it's good to know that they exist. But typically, if you notice down here, there is a small little note that I put here, is that we must avoid using all of this. We do not use these terms. Okay, so electricity, light, heat, thermal, sound, all of these are no longer energy stores. Okay, they are no longer energy. All right, so which means that out of all of this itself, these are all your energy stores, and the one I highlighted are typically the common ones that we're dealing with. Okay, so do take note about this. And then next, don't forget, just now we talked about the stores, the stores. Right now we're going to talk about the middle part, the process. How do we transfer energy? Okay, now we transfer energy loosely mainly because of your work. So this work itself, if you all remember, work done is force times distance. The mechanical work refers to this, therefore you can see the keywords force and distance, because that is basically the mechanical work done. So you can see I actually just add in the word transferred mechanically from what store to what store and stuff like that. Then depending on what you have electrical, you have your heating, you have your waves. So if you notice, all of the ones that have been removed from the energy store, like your heat, like your electricity, like your light and wave, light and sound, have all been actually transferred, converted, or basically became the process in which we transfer the energy. So for example, if you were to just clap your hand, if you clap your hand itself, what happens is energy is actually transferred via propagation of waves, because when you clap your hand, the kinetic energy store from your hands will actually go to the kinetic energy store of the surroundings, because when you clap, sound is traveling, moving outwards, right? So because it's moving from your hands to the air that is moving away from your hands, it is kinetic energy store to kinetic energy store of the hand to the air itself or your surroundings. So just be careful. Most of the time, we are actually dealing with mechanical itself. We don't really use the bottom three. However, usually when you first start learning this chapter itself, the schools will probably introduce this few as more common examples itself. But the more standard one that we will be using throughout the entire lesson will actually be your mechanical itself. So when in doubt, mechanical is the way to go. All right. So you can just read the rest itself. You can see basically electricity. And if you were to look at your syllabus, like your whole Set 3, Set 4 syllabus, you realize that these three are actually your subsequent chapters after you have learned energy and pressure. So after you learn those, these three will be most likely the following topics afterwards. Okay? So let's talk about the word example here. So now, using energy stores and transfer, usually is that if you notice, keyword how energy is transferred. So when you see this kind of how question, or when you see this kind of describe question, describe the energy transfer. Okay, and next is small detail, no energy lost due to air resistance. So if we want to answer this kind of question itself, how do we phrase it? first thing, we always start with energy is transferred. So you can just imagine that there is 3 marks here. What does that tell us? There is 3 transfers. Okay, so 3 transfers itself, let's answer this question. Number 1, how is energy transferred? Energy is transferred mechanically. First thing first is from the person, right? So from the chemical potential energy stored of the person. Now, do take note for, if I'm not wrong, is for Catholic High, they do not include the word energy here. So it depends on your school itself, go and double check on the phrasing. Do you just say chemical potential store, or is it chemical potential energy store? Go and double check with your school itself, and you are transferring it to the kinetic energy store of the ball. Okay, so this whole entire sentence here is just worth 1 mark. Okay, then continue. Energy is transferred mechanically from the KE store of the ball to the gravitational potential energy store of the ball itself. Okay, so you can see that your energy is being transferred, or actually in this case there's 3 marks, right? So we can actually break up this part a little bit further. So we change it to the person, and then we will just say energy is transferred mechanically from the of the person to the of the ball. So you can see this is actually a 3-step process. So you can see just now in my original step itself, I actually just only have 2 sentences, right? And because there's no air resistance, we can't actually mention anything at all. So what I can do is I can actually break it up so that I can actually take out the intermediate step, which is basically from the CPE store to directly to the KE of the ball, right? So if I were to split it up, break it up individually itself, you can see that I can actually form 3 different sentences just to answer back this question, so that I get 3 marks. Okay, 1 for each. So you can see transferred mechanically. Okay, I'm just gonna highlight it so that you guys can see transferred mechanically, then from what store to what store, what store to what store, what store to what store, and key thing of what object to what object, of what object to what object, of what object to what object. So very important that you know which is which. Okay.